Hello, welcome to your learning channel. Today's topic is JavaScript Event Loop. At the end of this video, you will be able to understand what call stack is, you will understand what callback queue is, you will understand what microtask queue is, and also you will stop guessing and start predicting the behavior of asynchronous code. Now let's get started here. And uh, first, let's take a look at the nature of JavaScript. Naturally, JavaScript is single-threaded. This means it runs one thing at a time. So you might wonder, how can it handle timers, API calls, or user clicks, and even those more tasks that take a long time? So if JavaScript waited for those tasks that take time, it would cause problem of freezing. Your browser would freeze, and this is waste of time. And JavaScript has a special way to handle this. So now let's take a look at a call stack before we go any further. So call stack is a last in first out data structure that keeps track of function execution. So every whenever you call a function, so it is call stack's responsibility for its execution. Now let's take a look if we have uh, a simple function. Let's say it is called, I have a typo here, function called grid. So now function console. So when we call this function, it is moved to the call stack for execution. But this is the synchronous task. So let's take an example when, let's say, we have the synchronous task, and let's keep this one, and also some tasks that could take a bit of time. So let's say we have this one as the first task, and we have the other one. Let's use the timeout. Yes, let's say it will take 1 second, and let's say it is consoling. Uh, so let's say we have this. So when we run this program, the synchronous task will first we directly be moved into a call stack, and they'll be executed. And when it comes here on timers, the 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 JavaScript will not wait for this 1 second. It will, let's say we have the other operation like this, like this. So when JavaScript gets here on the timer, it will not wait here for it to run in order to move to this. It will take this callback of say timeout and move it to web APIs to handle it, and then move on to the next operation. So now let's see the output for this. So as you can see, this last operation comes before the second one, which means um, let's take a look at event loop here, because this is where it comes in. So when the execution was taking place, this first one executed directly as it is synchronous operation. We moved on to the second one. This one is not synchronous, so it takes time. So event loop moved it to web API to handle it, and once it was finished, it moved it into what we call callback queue or microtask queue to wait for the recent operations that are actually being executed, which was this one, the last operation. So this is why on the output we can see we have the first one here and the last one, because this is synchronous, and it it will come before this because um, this Microtask queue has lower priority actually. So we get on that later to differentiate microtask and macrotask. So now, as you can see on the output, we have this one comes first. This one was moved to the web API, but we did not stop here. JavaScript moved to this and then come back on this later. This is how actually event loop works. So it is there. It is actually mechanism that continuous keep continuously keeps checking if the call stack is empty. If it is empty, it pushes the next operation. If it is not, it moves on to the other operations. So like we saw it in this example. So now let's take a look at the difference between um, macro task queue and micro task queue. So now let's say here we have the promise. So we have the first one, which is synchronous. We have the second one, which is timer. Now let's say we have the promise, right? So let's create a simple promise that is being resolved. And let's add handler to this promise to get its response. Let's say you're considering the response on this example, how event loop will work with this. So first of all, we will start with synchronous operation. They will be moved to call stack directory. We will move to the timer, and this timer is taking a long time, so it will be moved to web API to handle it, and then we will not stop there. We will also still while we will be waiting for it, we will come here to the promise. This promise also takes time, so it will be handled and be moved in Microtask Queue. So there's two things here. So we have this timer that are moved to web APIs, and once they are done with handling, it will be moved to Microtask Queue. So we have Microtask Queue that stores timers, and we have Microtask Queue that keeps promises. So now, how does event loop handle them? So once once the call stack is done with this first synchronous operation, it checks microtask before macrotask because microtask queue has higher priority than macrotask. So that's why this promise will come before this set timeout. So now let's check it out on the console. So as you can see, this promise came before the set timeout. This is the priority matter. So microtask has higher priority than macrotask. So and there is a trap that most people fall in when we have a timer that has 0 second as the delay. So when you have 0, it doesn't mean that this operation will be kept in microtask, and event loop will move to microtask once the we move to macrotask once microtask is empty. So that is why still this promise will come before. Let's take a look at it. So as you can see, still timer comes last. So uh, key takeaways from this, we have seen how JavaScript runs. We have seen what event loop is and how it works. We have seen call stack, and we have seen difference between microtask queue and the macrotask queue. So thanks a lot. See you next time. Remember to like and subscribe. Thanks.